welcome to the another very important session in which we will be discussing some more important questions and the concepts for our upcoming CSIR NET and the GATE Physics exam. So I hope that the discussion which we will be doing today in this session will be getting clear to all of you. But in case if there will be anybody having any doubt anywhere in the discussion we will be doing today in this session, you can surely let me know about it and we will try to consider those points in the session then. And if everything will be getting clear to all of you guys, then that's great. So today we are gonna work on the quantum mechanics questions, and these are the questions from where there are great chances for all of you to expect similar kind of questions, these topics based questions in your upcoming exams. So this is how everything we will talk about today in this session will be helping you a lot. So let's just start the discussion about the some important points first of all, and after that we will be continuing the discussion about rest of the other important things. So guys, the first thing is I'm going to show you some slides regarding the Unacademy learning app, and after that we will go ahead to do the more discussion. So this is about the Unacademy learning app, this is about the session, this is something about me. Here we are having the information about the community feature, and next I'm going to show you the slide regarding the iconic subscription. What are the benefits you will get if you will take the iconic subscription? All that has been shown here on the screen. And even now the important notes are available on the learning app, which will be helping you to take your preparation to the next level. Even guys, by using and by applying the code that is Anjali A Live as mentioned here on the screen, you will be able to get the discount in the total subscription amount. In upcoming days, so many new courses by the top educators will be starting on Unacademy, which will be helping you a lot to do the best preparation for your next CSIR NET exam and the upcoming GATE exam and other similar exams as well. So if you don't want to miss these important courses, or even if there is any of your friends, those who want to start their preparation for the upcoming exams and they don't want to miss out these things, you can share this information with them too. And anybody will be using the referral code Anjali A Live while taking the subscription. After applying the code, they will be able to get the discount in the total subscription amount. Here we are having the information about the plus subscription, and here we are having the information about the light subscription. The comparison between the plus iconic and the light subscription can be done with this slide, and all the details have been clearly shown on this slide. So I hope each and everything is getting clear to all of you. But in case if you will have any question or query, you can just let me know and we will go over that part as well. But if everything is clear, I'm gonna start taking the questions from quantum mechanics now. You will find that there are going to be so many different type of questions we will have, from where you can expect the like questions in upcoming exams. The type of questions we will talk about, similar to that you can expect. Okay, so everything we are going to talk about is very much important, and you should not miss anything from this section. Even if you are the one who has not started the preparation for these things till now, or will be starting the preparation for the next exam, still this session can be helpful for you, because I'm going to explain all the important points along with the discussion today, so that you will be getting that how to proceed, what concepts to relate, how to solve it, okay, and everything. So first question, quite easy, but one important point is hidden in it. So let's see how many of you are gonna get that or will be focusing on that. If you will not be able to get it, I will be the one who will let you know right now, like, okay, this is what can be done here, and this is how we have to be careful about the point which is important in this section. The wave function of a particle is given by psi is equal to 1 over root 2 phi naught plus iota phi 1, where phi naught and phi 1 are the normalized eigenfunctions with energies E naught and E1 corresponding to the ground state and first excited state respectively. The expectation value of the Hamiltonian in the state sign is. Options are E naught over 2 plus E1, E naught over 2 minus E1, E naught minus 2, E1 over 3. Option D is E naught plus 2, E1 over 3. Try it now and let me know what is the right answer according to you. And you can just mention it in the comments, whatever is the right answer according to you. If you are not going to get it, I will surely be helping you in that case. I'll let you know what are the steps you have to take and how you will be able to work on any such type of question. Okay, so all that I'm going to explain, but before explaining and starting to work on the answer part, I'm going to give you some time so that you can go through the steps you are going to consider to solve it, and you can get to know whether you are doing the right thing there or no. And that's how we will be just proceeding further to talk about what needs to be done. Okay, so go over the question and the answer steps. And whatever is the right answer according to you guys, you can just quickly mention it. I'll talk about that. Waiting for your reply, but nobody has mentioned anything till now. Okay guys, let me just tell you. So basically, here when you have this wave function and you want to find the expectation value of Hamiltonian, you need to know that there is a most popular expression in the quantum mechanics that says H psi is equal to E psi. So when you consider the Hamiltonian, its eigenvalue is what? Energy, right? So when you want to find the expectation value of Hamiltonian, it will give you summation over n, E n, P n as the value, where P is the probability of finding the particle in that particular state, okay, for which you are going to write the energy. For example, there are two energies given to us. One is E naught. Corresponding to that, we have to take the P naught as the probability, and then E1, and then we have to take P1, right? So in this case, what will happen? You have to work on finding the probabilities, because for this particular state, energies we directly know is E naught and E1. But what about the probabilities? So probability, how we find for any such kind of wave function given to us, in which we are having the superposition of different states given to us here. So its particular favorable state coefficient square divided by the sum of square of the coefficients. But when you do the square of each and every term separately, you have to take the mod after taking the square. So it's going to be 1 over 2 upon 1 over 2 plus 1. Okay, 1 over 2 upon 1 over 2 plus 1, and then next one will be what? This is going to be the probability we have written and the energy multiplied to it, plus what about this? Iota square is its favorable coefficient. Okay, so iota square will give you -1, but when you take its mod, it becomes +1. So 1 E1 divided by 1 over 2 plus 1. What it will give you in the denominator? 3 by 2. And when you will get that 1 over 2, 2 over 3, that will give you 1 over 3 E naught plus, that's going to be 3 by 2 here. So that will give you 3 by 2, right? So 2 by 3. So 2 by 3 E1. This is what you will have. It will give you E naught plus 2 E1 divided by 3, which is your option D, which is the correct one. So you can easily find the answer this way, and if in case still you will have doubt and difficulty in this part, you can just let me know. We can talk about that. But if it is getting clear, then that's great. We are ready to take the next question. Okay, if you have any question anywhere till now, you can just quickly mention it. I'll talk about that. But if everything clear, let's take the next one. So here is your next question based on another concept, and that is, if the perturbation, that is S dash is equal to AX, where A is a constant, is added to the infinite square potential Vx is equal to 0 and infinity. 0 for x lying between 0 and pi, or otherwise its value is what? It's going to be infinity. The correction to the ground state energy to first order in A is options are, I'm going to write them here so that everything will be on one single slide. A pi over 2, option B is A pi, option C is A pi over 4, and option D is A pi over root 2. Try it now and let me know as you will get it done and what is the right answer according to you. If you're not gonna get it, I will help you in that case. So try to get the answer and let me know what is the right one. So if the perturbation S dash is equal to AX, where A is a constant, is added to the infinite square potential, Vx is equal to this, the correction to the ground state energy to first order in A is. So if we are going to talk about this one, what will happen? The perturbation is given. Expectation value of this perturbation, whenever it's a variable perturbation means what? It's a function of x or any such value. You can have the different values existing for it. Okay, so that's a kind of variable you are gonna have. So when you have a function given to you, something similar to that part, what next you have to do? You have to find its average value or the expectation value. When you will find its average value, okay, in that case what will happen? In that case you have to just find the average value for the x, okay, because a is already a constant. So a expectation value of x, when you will do that, what will happen next? So x means 0 plus pi over 2, right? So 0 plus pi over 2 means a pi over 2. This is what you have to do. Now once you're going to consider that, it gives you that your option A is the correct one. Even it can be solved with a detailed approach of the perturbation theory, but it is going to help you to save your time. So simply find the average value of the perturbation applied to the system. Since you know the extreme values of x, they can be 0 and pi. So 0 plus pi over 2, that is a pi over 2. You will have overall value, and that's your first order correction to the ground state energy. This is how you can simply find it, and it was the formula we used here. If in case anybody is having any doubt, you can let me know. Otherwise, I'm going to give you the next question, which is here. A particle in one dimension moves under the influence of a potential that's going to be Vx is equal to Ax to the power 6, where A is a real constant for large n, the quantized energy level En depends on n as options are En is approximately n cube. Like it depends on n cube, that's what they want to say. And En is proportional to n to the power 4 by 3. Or this is going to be dependent n to the power 6 by 5. N to the power 3 by 2. Try it now. Let me know as you will get it done that what is the right answer according to you. So basically here it's going to be n to the power 2n over n plus 2. That is 2 times 3, 6 over 6 plus 2. Now what has been done here? So whenever you know that potential depends on x to the power nu, okay, let's say this is nu. And this is for a system we had the potential. So in that case, what will happen? There will be energies of the different states of the system. Let's say for nth state, you want to know what is the energy dependency on n, on that same nth state n. Okay, so it is going to have the formula n to the power 2 nu over nu plus 2. This is what you have to consider here. So when you are going to consider that part, 2 nu, what is the potential dependency on x in this case? It was 6. And that is at place of nu, I have taken x to the power nu, x to the power 6, right? So it will give you n to the power 2 nu, which is 2 times 6 over 6 plus 2. That is going to be 12 over 8. So 4 3s are 12, 4 2s are 8, 3 by 2 is something you are going to get. And that gives you the option D to be the correct one, right? And this is how you can simply find it. Tell me if in case there is anybody having any doubt in this part, we can talk about it then. But if it is getting clear, that's great. We'll go over the next question now. So you can see how easily for the questions we have done till now, you are able to get the concept, you are getting to know about the conditions, when to use what formula, how can we solve a particular type of question easily. So all that will be getting clear to you. But in case if you're gonna find like, no, I'm not getting something clearly, you can just surely ask it in the comments and I will try to make it clear to you. The energy of the first excited quantum state of a particle in the two-dimensional potential v as a function of x and y equal to half m omega square x square plus 4y square is. Options are 2h squared omega, 3h squared omega, 3 by 2h squared omega, and next we are going to have is 5 by 2 h squared omega. You can try it now and let me know what is the right answer according to you. And if you will not be able to get it, I will be explaining that part then. Sync GP. For most of my sessions, you will be getting like the language for it, mostly English. While if you don't get anything clearly and you want me to explain it in Hindi, अगर आपको कहीं पे कुछ भी समझ में नहीं आता है एंड यू वांट मी टू लाइक, अगर आप चाहते हैं कि मैं उसको हिंदी में एक बार रिपीट कर दूँ, एक्सप्लेन कर दूँ, तो आप मुझे बता सकते हैं, वी कैन टॉक अबाउट इट. डन. तो हम फिर वो हिंदी में भी डिस्कस कर सकते हैं, बट नॉर्मली जो सेशंस है वो इंग्लिश में है फॉर लाइक माय सेशंस. डन. एंड तो कहीं पे भी अगर आपको डाउट होता है, नहीं कुछ समझ में आ रहा है, क्लियर नहीं हो रहा है, तो आप वो बता सकते हैं, मैं उसको आपको हिंदी में एक्सप्लेन कर दूँगी, ऐसा हो सकता है. डन. Okay guys, try this one and let me know as you will get it done that what will be the right answer for you, and if you are not going to get it, you can tell me, I will explain that part. Otherwise, just in some time I'm going to talk about it. Yeah, that's great, Sanjay. And how was it? How did you find the exam? And what were the topics you found there? Like, were these most common topics you got, or something different you find? Okay, how was it? So basically, guys, for this one, first of all, you have to compare the potential with the standard expression of the potential for the harmonic oscillator, because you know that its harmonic oscillator potential expression is half m omega square x square plus half m omega. For example, omega x, omega y can be different, so I will be taking a different notation for them too. Okay, so omega y square, right? Now, what will happen when you are going to compare it? You will just break it into two parts. You will see you are going to have the 4 present extra term, okay, here. So, what we will do, can I write it this way? I'm just going to show you here on the side. Half m omega square x square plus half m 2 omega square y square, right? In that case, what will happen? This is omega x and this is omega y. Oh, sorry, omega x, and the second one is omega y. So what is the omega y value we are going to have? That is 2 omega, right? Now, in that case, now we need to recall the energy expression for the harmonic oscillator. So what is that? That's going to be n plus half h squared omega. So nx plus half h squared omega x plus ny plus half h squared omega y. This is what we can have, right? Now in this case, what will happen? Nx is going to be like starting from 0. Nx and ny both values start from 0 for the harmonic oscillator. Okay, so n values start from 0. If I want to find the minimum energy from this expression, I can plug in nx0, ny0. Okay, because that will give me minimum value. But you already know that omega y is 2 omega and omega x is omega. So now you want to find the first excited state energy. So what you will do in that case, 0, 0 was giving you for nx and y values the minimum energy, okay, the ground state energy. For finding the first excited state, you have to take the nx and y values in such a way that you are not skipping any value in between. So for that reason, I will take nx1 and ny0, right? And when I'm going to do that, what will happen in that case? It's 3 by 2 h squared omega plus half h squared 2 omega. 2 cancelled out. So 3 by 2 h squared omega plus 1 h squared omega, which will simply give us the 5 by 2 h squared omega. So this is how you got the final answer, and this is your option D, which is the correct one. Tell me if any step is not getting clear to you and anything you want me to explain. I can talk about it and we can consider that part too if something is not getting clear to you. Okay, but if you got like, okay, this is what needs to be done. Firstly, we have to simplify the potential. We need to categorize omega x, omega y. What are their values? Once we get that, then we have to just plug in the expression, the nx and y values in the energy expression itself. And this is how we are going to get the final answer, right? So it was quite simple and easy. But these things become easy actually when we keep on doing the practice, when we are gonna focus on what is important, how to consider the values, what we need to be careful about. Because sometimes even students make mistake in the easiest parts. Okay, so in that case, like, what is the reason behind it? Just because we were not taking care of these points, that what is most important to focus on in a particular section. When you start focusing on those parts, you will not make mistake, and you are gonna be right all the time. Okay, if everything is clear till now, I'm gonna give you the next question now, guys. And still, if you will find something is not getting clear, let me know, let me know. Here is the next one. Again, a little bit different concept based, but you will get the information about it. So for that reason, we can include this too here. Let psi and lm denote the eigenfunctions of a Hamiltonian for a spherically symmetric potential VR the wave function psi which is equal to 1 over 4 psi 210 plus root 5 psi 21 minus 1 plus root 10 psi 211 is an eigenfunction only of options are 2 okay h l square and lz. Next one is h and lz. Next one is h and l square. Next one is l square and lz. Now let me know which one you think is correct and how you are going to consider it. If you are not getting familiar with what steps you can take and how you can proceed further, I'll be helping you in that case, and I will let you know how to identify what is the right answer. And still, if you will have any doubt or difficulty, I will be talking about it. Waiting for your reply, guys. Let me know what do you think is the right answer. So wave function is given to you. You have to consider it is the eigenfunction only of what. So in this case, what will happen? In this case, you have to consider that how you find h. So your h value, which is Hamiltonian, and you know its eigenvalue is energy, means it's similar to what you how you find the energy of any system. So you know energy depends on n, which is the principal quantum number. So here if you will see, the principal quantum number is 2, 2, 2, because it is NLM notation. So first one is principal quantum number, second one is orbital, and the third one is magnetic. So 2, 2, 2, which is equal, right? And in that case, what will happen? You have to consider the E2, right? And when you consider the E2, will it be same for all the states? Even if you're going to get some constant outside, that's all right. But other than that, it's not going to remove any of the wave functions or the states from the overall system. So that means it is the eigenfunction of energy or the Hamiltonian. You got that, okay? But at the same time, if I will talk about the uh, LZ. Oh, before that, let's consider L square, which is L, right? So in that case, you will have L into L plus 1 h square. So when it is the case, if you will see the L values in all the terms, it's 1, 1, 1. It depends on the similar L values for all the three terms, right? So in that case, what will happen? It's even not going to remove any of the states from the overall wave function, and that's how you are just going to get it, right? So once you are going to consider this part, what next you have to do? The next thing is you have to check out for Lz. Means you got to know that it is also the eigenfunction for L square, right? What about Lz? That will be dependent on the m values, because you know it's going to be mh cut. So NLM, M. So m is 0 for the first term, and in that case, what will happen? In that case, you are not going to get this term to be non-zero in your final expression of wave function once you will operate Lz there. So in that case, it's not the eigenfunction for Lz. And that means your answer must have just h and L square in it and not the Lz. And that gives you option C to be the correct one. Tell me still if there is any doubt, and this is how you can check out whether it's a eigenfunction for a particular case or no. So for L, it's Lz, it's not, and for all other, it is yes. Okay, I hope you're gonna get it now, guys. But still, if there is anybody having any doubt and you are not gonna understand that part, tell me. I'll talk about it. I'll just try to make it clear to you. But if everything is getting clear, then that's great. We can take the next question now, and it is here. This time I'm gonna give you some time to work on it because it is similar to what I have talked about in this session itself, and just a little bit modification and a little bit understanding with the question statement will be helping you to get the answer for this. The energy eigenvalues of a particle in the potential Vx is equal to half m omega square x square minus ax r. Options are En is equal to n plus half h squared omega minus a square over 2m omega square. En is equal to n plus half h squared omega plus a square over 2m omega square. Option C is En is equal to n plus half h squared omega minus a square over m omega square. And your option D is En is equal to n plus half h squared omega. Try it now. Let me know as you will get it done. If in case there will be anybody having any doubt, we'll talk about it. But whatever is the right answer according to you, just mention that. We will be trying to consider that part as well. So giving you some time to work on it. What you have to do, let me just give you some hint. Potential expression is given to you, but you know this is something similar to the harmonic oscillator, but not exactly same because AX is the extra term present there. So what we will do, we can take half m omega square common and we can try to make the complete square after that, which will contain the x terms, and remaining constant terms you will add and subtract its square to make it a complete square. So you will just get that remaining term, the constant term at the end, and the overall the term you will make the complete square will be behaving as the harmonic oscillator's potential. It will be similar to that expression. So in that case, its corresponding energy expression will be n plus half h squared omega, and remaining constant term will remain as it is. That's it. This is what you are going to do. So now I'll be waiting for your reply, and if you will not be able to get it, I'll help you then. But I want you to even try it. So let me know if you want me to start working on it and you want me to solve this question. Waiting for your reply, guys. Otherwise, I'll be starting it soon. Try, try, try. Okay, let me just tell you the steps you have to take here. So basically, in that potential, we will be taking half m omega square common first of all. So the remaining term will be x square minus 2ax over m omega square. Then, if I'm taking it as a square and considering the second one as 2ab, so what is b here? B is a over m omega square. So add and subtract the a over m omega square and add and subtract this value, okay? Now what will happen? Once you've done this, a square minus 2ab plus b square, right? This is what you are going to have. And the last term is just the extra one, okay? This is how you are going to get the potential same as half m omega square a minus b whole square, that is x minus a over m omega square whole square. Then you will have minus of half m omega square will get cancelled out with one of the m omega square, so remaining term will be this. So this is same as the capital X if I will write here, okay? This is what capital X you had. So this is capital X square, so half m omega square x square minus of this value. So its energy will be n plus half h squared omega minus a square over 2m omega square. This is what you will have. This is your potential expression. Now what next? The next one is, once you got it, you are getting option A to be the correct one. You can see that option A expression is same as what we have got. So let me know if still there is anybody having any doubt. We can talk about it. And if everything is clear, then that's great, great, great. Next question based on another concept we will take. But I'm just going to check out your comments if you are having any doubt anywhere. And if no doubt, we are ready to take the next question. So you can see till now, it's just few minutes we had, okay, when the session has been started. Since then, how many concept-based questions we have done? Perturbation theory we have done, probability-based, expectation value-based, Hamiltonian and the angular momentum, z component of it, okay, and based on the WKB approximation where we have got the n dependency on n, and so many. Now we are gonna do the commutator bracket based question. So you can see how many concepts we have involved here. We talked about them, the tricks, the concepts, the expressions. So if you do the preparation in the right way, even in the less time, most of the things can be done, right? And you should have a proper guidance, like who is going to let you know, okay, this is what needs to be covered up, this is how it needs to be done. And when you get to know these things, it's surely going to be helpful, makes you confident, makes you more like uh, more having a better command on the things, right? So this is how everything will be helping you if you're doing the preparation in the right way. This matters. Clear? Let's take the next question now and let's cover up one more concept. Given the usual canonical commutation relation, the commutator A comma B of A is equal to x p y minus y p x and B is equal to y p z plus z p y is. Options are h good xpz minus pzx, negative h good xpz minus pxh, option C says h good xpz plus pxz. Option D says negative h good xpz plus pxz. Try it now and let me know what will be the right answer according to you. If you don't know how to proceed further and how to get the answer, I'll help you in that case. I will let you know the right approach and the easiest one which will give you the right answer too. So I'm gonna wait for your reply to work on it, and if you don't know what to do, I will let you know soon. But giving you some time to think about it and to consider, like, oh, this can be done, that can be done, this is how it can be solved, this is how it can be solved, like anything you want to consider. Let me know, let me know. Are you trying? If you do with the detailed approach for this one, it may take time, but if you will do with the approach, I'll be assuring it will be done in few seconds, because I'll be explaining it and sharing it with you. I may take some time to explain it properly, but when you will do it on your own after getting a clear idea about what needs to be done, you'll find like it's quite simple and easy for you to done and to solve it. Still waiting for you to try and solving it. Okay, let me just start the discussion. So actually, guys, here we have to find the commutator bracket of A with B, right? There is one approach which is direct, simple. Like simply use the formula for A and B when the added terms are there, the multiplied terms are there. So you have to split the things with the formula. It will take a lot of time. Step by step, you go for this. Now, I'm going to tell you the approach I would like you to work on and which will make it quite easy for you. So, iota somewhere outside because it's common for the first term. Xpy minus ypx, xpy minus ypx, comma, what next? Ypz plus zpy, ypz plus zpy. This is what you will have. Now, split the terms. So, how it can be splitted? The first term with the first term, first term with the second term, second term with the first term, second term with the second term. Okay, this is what we will do. Iota outside, xpy with the ypz. Then I have taken the correct notations or no. Let me just check once. Xpy minus ypx, correct. Ypz plus zpy, correct. It's done. Okay, next. Plus iota xpy comma zpy, the second term of the second one, and minus iota zpx comma ypz minus, no, yep, no, yep, let's check, yep, it's second term we are taking, iota ypx comma, it's going to be, Johnny, we will be talking about it after the complete analysis and exactly on the basis of how everybody has worked on the things. So soon and slowly we'll get to know what it can be, because whatever anybody will suggest you will be just the expected cutoff, not the exact official cutoff, will be just the one which will be declared by the organization. Okay, so soon you will get a session on this. Now, if I'm going to talk about the next thing, it's going to be, you have to now consider the pairs like x with y. What it will give you as the commutator bracket of these two, 0, right? X with pz, what it will give you, it is even gonna be 0. But py with y is non-zero, and what is that? That is going to be negative iota h cut, right? And py with pz will be what? It will be 0. Okay, so only one non-zero value you are getting, that is py with y, which is negative iota h cut. And since x is on the left hand side and pz is on the right hand side, so it will remain same. So negative iota h cut, x is on the left hand side and pz on the right, so we will write it as it is. Now for this one, x with z 0, x with py 0, py with z 0, py with py 0. So we are not getting anything from here, so plus 0. Okay, and now next thing, y with y 0, y with pz 0, px with y 0, px with pz 0, nothing, 0. Okay, y with z 0, y with py, we will have iota h cut. Only this is something which will give us a non-zero value, so iota h cut. Okay, px on the right hand side and the z on the left hand side. It is left hand side in the product, right? So it will remain as it is, and it's going to be px on the right hand side in the multiplied term. If you will look at it, y px, so px is on right, that's why we are writing it on the right hand side. Now this is what you got. Iota square is minus 1, so minus minus plus h cut, let's take it common. Here also minus minus plus, for iota square you will also get a negative sign. Next is xpz plus zpx. This is what you will get. So what you will have next, you can see what option we had was with the same expression, xpz plus zpx. I think it's option C, which is closest to this one. Okay, they just have written pxz. Yep, just a little bit change in the expression while everything else is same. In comparison to other options, the most appropriate option is option C, so we'll go with that. We are gonna consider it to be the correct answer. And this is how you can see how easily we're able to deal with all the terms, the combinations, the answer you will have, and this is how you're reaching to the final answer. Tell me if in case you are still gonna have any doubt. We will be trying to consider it, and if everything is clear, that's great, great, great. If there is any doubt, just mention that. I'll be talking about it then. Otherwise, I'm gonna give you the next question, guys. So if you're gonna find that something is new for you and you are having difficulty in understanding that part, you are not able to get it clearly, what should be done, how it should be written and all, so you can ask that. I'll try to make it clear to you. Next question is ready. So we have to take a slide to make it clear. If you will have any questions, you can surely ask that. Here it is. A particle is prepared in a simultaneous eigenstate. Of L square and Lz. If L times L plus 1 h square and mh are respectively the eigenvalues of L square and Lz, then the expectation value of Lx square of the particle in this state satisfies options are Lx square, expectation value of Lx square is equal to 0. Expectation value of Lx square with within 0 and L square h square can also be equal to these values. It can be asked as a, you can say, formula based question like this, or it can be asked as a numerical to you, means they can give you the specific values of L, okay, and the other terms, and then they can ask you what can be its maximum value, what can be its minimum value. That's how even they can ask you the questions, or its range, okay. So this is how you can expect it to be. L times L plus 1 h square over 2 L h square over 2 Lx eraser Lx square L times L plus 1 h square over 2. These are the different values they have given us. Now just consider what can be the right answer and how you are just gonna take the steps to solve it. If you will not be familiar with any of the steps, you can take care to work on this part. I will help you in that case. But if you can consider like, yeah, it can be done, or this is how you can take the steps and you can reach to the answer, then that's great. Asking you to just tell me in the comments what is the right answer for you guys. But if in case you will have doubt or difficulty in considering it, I will be helping you in that case. Okay, so for this thing you need to consider the steps which I'm gonna let you know now. As we all know, this is for what? This is for Lx square. They have asked you to find the expectation value, right? So as we all know that Lx square expectation value is equal to half of L times L plus 1 h squared square minus m square h squared square, and this is what we will have, right? Now, for the minimum value, you can see this term is already subtracted from some term, right? So if you want to get its maximum value, if this term will be 0, then what you are subtracting from the main value, that will be 0. 0 you are subtracting, okay? So it is going to give you the maximum value. And when you want to find the minimum value corresponding to it, you have to subtract the largest value out of the main value, right? So what will happen in that case, for the maximum value of it, you will take m is equal to 0, and for the minimum value of it, you will take m is equal to L, right? And this is how you are just going to get the final answer. So you will see that what values you are going to get after taking these values there for getting the maximum of Lx square expectation value and minimum of Lx square expectation value. It will be same as what option. I want you to mention it if now you are going to get it, but if no, I will let you know then. So when you are taking 0 for m, what you are getting is just this initial part, half times L plus 1 h squared square, which is same as this, right? And then when you are going to take this m is equal to L, so it will give you the L square h squared square. Is it L square or just L? Let's check it out. L h squared square, L square, and h squared square if you will have. Okay, this is also going to be L square, right? So this will get cancelled out with this L square h squared square term. So you will just have L square over 2, and that is this. So your option D must be the correct one then. Let me know if you are not going to get it or there is any doubt you're going to have. We can talk about it then. But did you see that how we are taking the steps and how we are just solving it by taking some of the steps here and making it easy? So if you're getting it this way, it is gonna be a formula based question, but you can also get it as numerical, and that will surely be helping you to work on the important things. Let me know if in case there is anybody having any doubt till now, we can talk about it. And if everything clear, that's great. Monica, yes, we will be starting the concept based discussion and the topics discussion in upcoming sessions. So these are the sessions which were already planned for this month, and after the sessions which are already planned, you will find the topic based sessions here where we will talk about the concepts, we'll take more theory part. Even the new courses will be starting on Unacademy for your upcoming CSIR NET and the GATE exam preparation. There also we will be starting the discussion from the basics, concepts, theory, and all that part first of all, and then we will go ahead for the questions, and even the tricks will be involved. So even if anybody is there who wants to join the live classes of well structured and well planned courses by the top educators, as we will have so many courses going on there, even in case if any day you are not able to join the live session, you will be able to check out the recordings, and that way you will not miss anything and you will be able to cover up each and everything. So if there is anybody who is planning to join these regular sessions, you can even check out the details on Unacademy Learning app about the upcoming courses. Even some of the new courses will be visible to you there later on. Okay, but many new courses will be starting in upcoming days for the next exam, and that's how everything will be helping you. And since you are having so many choices once you take the subscription to join the different courses by the different educators, and you will be surely getting the things clearly. So you can take the subscription in that case if you want, and that will surely help you to get all the benefits I'm going to show you even in upcoming slides. And you can use and apply the code Anjali Live as mentioned here on the screen to get the discount in the total subscription amount. Okay, so even if any of your friends will be taking the subscription or anybody will be taking the subscription, by using and by applying the code that is Anjali Live as mentioned here on the screen, will be able to get the discount in the total subscription amount. To get a clear idea about what benefits you will get in the respective subscription like plus, iconic, light, all the points have been mentioned here. In the plus and iconic subscription, you will also be getting the important notes which are now available on the learning app and which will be surely helping you to take your preparation to a very good level. So guys, anytime, whenever you will proceed further to take the subscription, and if you are the one who wants to start the preparation under the guidance of top educators and don't want to miss out the important courses and the classes by the top educators, then you can take the subscription now. Use and apply the referral code Anjali A Live as mentioned here. Okay, you can even note it down. The spelling should be same. It should be written as it is. Okay, and by applying the code, you will get the discount in the total subscription amount. Okay, so thank you so much everyone for joining this session, and you are surely gonna get many important sessions in upcoming days. And even in these sessions, I'm gonna try to explain you the concepts along with the questions, so that at least you will get familiar with what you are going to work on and what type of questions you can expect. Okay, uh uh Monica, after clearing LS, so basically there is going to be one thing, that there are different universities and colleges we are having, right? So some of the colleges and universities may even provide you the opportunity to join the college, okay, or to teach there on the basis of your LS, you will qualify. Some of the universities also ask for PhD, so you have to do a separate research for that, what colleges are expecting or accepting that LS qualification, and on the basis of that they are going to do the recruitment. And there will be some of the universities which are just going to ask for PhD qualification there. Okay, and you can even have more options, but yeah, there are choices you will have after qualifying LS for direct job. Excuse me. Okay, so let's keep it this much right now, guys, and thank you so much everyone for joining this session and for attending it till the end. Thank you, thank you, thank you. Bye, take care.